Hello. Today we're going to be working on compound inequalities. We're going to talk about some of the special cases and things that pop up. So as a reminder, compound inequalities are more than one inequality put together in a problem. Now, it will either be an and problem or an or problem, and every single problem should tell you if it's an and or an or. Now I say that, and you might be looking at number one saying, well, she just said that it had to be like, tell me if it was an and or an or. This one, you can't see the word and or or. If you see an inequality that looks like this, specifically with the two inequality parts like that, that means that this is an and problem. And it's assumed, not assumed, it's telling you it's an and problem based off of the way it looks, but without the word. Okay, so this is an and problem. So when you're looking at this problem, it's like, what do I kind of do with this? Now that I have two inequalities, I don't really know how to solve that. So I want you to pretend that we only had part of it. And if we just had this part here, negative 5 is less than x minus 9, you'd look at that and say, well, wait a second, I can solve that. But then we're going to cover up this other part and say, well, wait a second, if it was this, could you solve it? And you'd look at that and say, well, I could solve that. So you have two different options. Option number one is to rewrite each inequality with the word and in between, kind of just covering up each half, and then you can solve each part and graph it. I'm going to show a different method because I'd like to go a little bit faster than that personally, but if you like breaking it up like that, you can absolutely do that. I'm just going to kind of treat this like I have two equal signs in the problem. Normally with x minus 9, you'd look at that and say I'm going to add 9. So to be fair, I'd have to add 9 on both sides of my equation or inequality. So I'm going to do the same thing. It's just I have to do it on 3 separate parts to keep this overall inequality balanced. So I'm going to get 4 is less than x, which is less than 19. So I'm solving both of the inequalities at the same time. So looking at this, this is actually saying 4 is less than x and x is less than 19. You don't have to write it out as separate parts here, but this is just showing you exactly what this part up here is saying. So to graph it, you're going to go to 4. 4 is less than x. That means x has to be bigger than 4, which means we want everything to the right of 4. And as for 19, we want everything smaller than 19. You'll notice I'm using open circles for these ones. So you solve it, you graph it, and then you wait and think about it for a second. This is an and problem, which means I want the overlap, which means I want everything here in the middle. So then you're going to graph your final solution as 4 and 19 and everything in between. So I do want to see your final graph here. So your solution in set notation is going to be x such that, and then 4 is less than x, which is less than 19. We do push it together like that in set notation. For interval notation, the farthest to the left that the graph is shaded is 4, but it doesn't include 4 because of the open circle. And then it goes to the right to 19, but again, parentheses because of the open circle. So let's take a look at now. Number 2, this one has the word or. So it's telling you exactly what you want to do with the or problem. It's whatever works in one or the other. It's the union of the two. So for problem number 2, we're going to go ahead and solve for x. We're going to subtract 2 from both sides of this first inequality and then divide by 3. And we get x is greater than 5. Or now we're going to go ahead and have to solve this other inequality. So we're going to move the 5 over. 2x is less than or equal to 2. And then divide by 2 to get x is less than or equal to 1. Notice my inequalities are different for this one. They both don't have to be like or equal to. You can have an open and a closed circle on your graph, and that's okay. So for this one, I'm going to graph x is less than, oh, nope, I have to do the 1 over here and the 5 over here. I want everything bigger than 5, but not including 5, or everything smaller than 1, including 1. Since this is an or, I want anything that's traded in one or the other. It's the union of the two. So when I go to graph my final answer, it's whatever is shaded in either one has to be part of my solution set. So it would look like that. So therefore, in set notation, I solve for x such that, and any OR problem that has two separate chunks has to be written separately. So we're going to go left to right, x is less than or equal to 1, in union with x is greater than 5. Now that big U, as a reminder, means OR. In interval notation, on the left is negative infinity, and 1 here should have a bracket because it's filled in. That chunk is in union with 5, infinity, and 5 has a parentheses. There's two separate chunks, so I write both of them in interval notation. So let's take a look at number 3. Looking at this is an AND problem only because it's squished together the way it is. So I'm going to go ahead and add 4, but I have to add 4 in all of the different parts to my inequality. So I get negative 2 is less than or equal to negative 2x, which is less than 14. So then I'm going to go ahead and I'm going to divide everything by negative 2. And some sort of alarm should go off in your head right now because we're dividing by a negative. So when we divide by a negative, we have to switch our signs. Now we have to switch both of our signs for this one. So 1 is greater than or equal to x, which is greater than negative 7. So now, as I'm looking at this, I'm going to write this the other direction. Negative 7 is less than x, which is less than or equal to 1. Just because we're used to seeing it from least to greatest with the less than. Now looking at my graph, I'm going to graph negative 7 and a positive 1. For negative 7, I wanted everything to the right of it, and it should be an open circle. For 1, I wanted everything filled in for that circle, and then everything to the left of that. And problem means it's going to be the overlap. So I want everything from negative 1 or negative 7 to 1, not including negative 7, but including 1. So to write my answer in set notation, I'm going to do squiggle x such that negative 7 is less than x, which is less than or equal to 1. In interval notation, we're going to do negative 7, comma, positive 1. Negative 7 has a parentheses, 1 has a bracket. So 4, 5, and 6, these ones are going to be some of those weird cases where things don't kind of turn out the way you think they might. So we have an OR problem for this one. We're going to go ahead and take each inequality and we're going to solve it for x. So for our first one here, we get x is less than 4. Or, and we're going to go ahead and take the next inequality and we're going to solve that one. And this one we have to divide by a negative, so we have to switch our sign from greater than to less than. So x is less than negative 2. And so looking at this, I'm going to go ahead and graph these. Negative 2, I want an open circle and everything less than that. For the 4, I want another open circle and everything less than that. So you solve them, you graph, and then you stop and you think for a moment. This is an OR problem. So this is kind of like that cats and dogs one from yesterday, where we're looking for anything that any owner that had a cat or a dog, which means it's going to encompass everything that was up to negative 2, but then since it's OR, it's going to go all the way up to 4. So my final answer is everything that was shaded in either one gets put together on my final graph. Since 4 didn't work in either one, it's going to be an open circle. And so now with my solution, I am only looking at this solution that I've highlighted here on my number line. That's the only solution I talk about here. So this is x such that the only thing I have highlighted there is everything less than 4. So that's the only part I write there. Likewise, in interval notation, it's from negative infinity to 4 because that's the only thing that's shaded on my number line. And notice that other part there, x is less than negative 2, is already incorporated into that answer. So let's take a look at this next one here. We're going to go ahead and solve each equation for x. Here's another one where you are dividing by a negative, so you switch your sign. So you get x is less than 3, or So for the next one, we distribute, and then we move everything to the other side. We get 2x is less than or equal to 10. So x is less than or equal to 5. So we're going to have 3 with an open circle and everything less than that shaded. And then 5 with a filled in circle and everything less than that shaded. To know what to shade, we go back to our word, it's over. So you have to see it in either one. So everything up to 3 works, but then since 3 to 5 works in one of your solutions, it's going to work in the overall solution. So your final answer is going to be everything shaded here up to 5. Since 5 worked in one of your inequalities, it's going to work in the overall solution. Which means my final answer here is going to be x such that, and again, I only look at my final graph that I have here. Everything less than or equal to 5 is going to be the summary of my answer. So from negative infinity up to 5 with a bracket in interval notation. So let's look at one of these weird cases that has the and. So we're going to go ahead and solve each of these. The first one I distribute that -2, but I'm not multiplying both sides by a negative, I'm just distributing the negative. So I don't actually switch my sign yet. Continue to solve for x. -2x is less than 6. Divide by -2. Here is where I switch my sign. So I get everything greater than -3. The next one, I'm going to solve for x. And when I do that, I get x is greater than or equal to -1. But the word in between here is the and, which means it's going to be the overlap. So when I go to graph this, I want everything bigger than -3. But then I also want everything bigger than -1. So I'm going to go to -1 on the number line, and I'm going to put a filled in circle because of the or equal to. And then it's everything that's shaded to the right. So with this being an and problem, I am looking for, oopsies, I am looking for my overlap. So it has to work in both of them. So the only place I see the overlap is everything bigger than -1. So I'm going to shade everything to the right of that. And at -1, you have to be careful. It has to work in both of them. So since it works in the top one and the bottom one because of the filled in circle, you're going to use a filled in circle here. If the bottom one was open circle, it doesn't work in both of them then, so it would be an open circle overall. So my solution in set notation is x such that x is greater than or equal to -1. In interval notation, it's -1 with a bracket, comma, infinity, because it's shaded to the right. So let's go ahead and take a look at this word problem here, an example of a compound inequality now in words. So we have a diet for a dog. The dog's name is River. So River consumes between this many calories every day. This means she has to consume greater than 510 and less than 540. This is an and problem. So 510 is my low end, 540 is my high end. We have to be somewhere in between there. So River right now eats 1.5 servings of dog food, which right now has 310 or 320 calories per serving. And we want to figure out how many treats. Now each treat is 15 calories per unknown number of treats. So we want to set this up and then we want to go ahead and solve this. So 1.5 times 320 is 480. And so now what we can do is we can go ahead and solve this like we were solving our other compound inequalities. And so we get 30 is less than or equal to 15x, which is less than or equal to 60. And so now River can eat anywhere between 2 and 4 servings of the treat. Part B is now the exact same setup, it just changes the calories to 10. So I'm going to let you solve this one on your own. It's the same setup, it's just now the calories for each treat are 10. So take a moment and try that, and thank you for listening to the video.